From the start of this project, we had a goal to significantly reduce the carbon emissions from the fuel we were producing.
The renewable gasoline blend was really a one-team effort where at Fuels Products and Technology, we worked closely with the Process Planning Unit, Experimental Assistance Unit, Product Engineering, Fuels Advocacy, the Richmond Refineries Quality Control Department, and CREG.
We start by taking renewable feedstocks like soybean oil, waste animal fats. We process them in facilities like REG Geismar's biorefinery or our own refineries like El Segundo. We then take those materials that come out of the refinery and blend them together with that target of hitting a 40% carbon reduction.
A lot of the focus during this project was really optimization of the boiling point distribution. One of the great things that we're able to leverage is the close interaction we have with our blending and our product engineering team. So we're really able to change these distillations and get feedback on a daily basis. And then we can iterate and make small scale blends to then determine if those are going to meet or exceed the industry standards for this material. There was a lot of validation work that went into making sure that this is literally a drop-in material you put in your existing car and you're not going to notice a difference. The entire goal is to not notice the difference.
We do tens of thousands of miles of testing and probably eventually millions of miles of testing to make sure that this fuel is going to perform under any environment. We start with the lanes that you see behind us where we can run the vehicles in place for 5,000 to 10,000 mile cycles, and then we tear down and check everything. And then once we're satisfied that we're not seeing any obvious defects, then we move on to on-road testing. So when we tested this on the road, we shipped vehicles to Arizona. We took a team of technicians, experienced vehicle testers, and we drove. We drove thousands of miles on the highways, going up mountains, testing the fuel in the toughest of conditions, driving up steep hills at high loads where the engine is pushing the fuel as hard as it can go. We want to make sure it still has the same octane performance, it has the same resistance to detonation that your normal fuels do. At the end of the day, we found out that this fuel performs exactly like it should.
It's pretty unique that you can have a material that works with all the existing vehicles on the road today. 265 million cars that work on fossil gasoline at the moment, and this is an alternative that can immediately lower the carbon intensity of that without any change in the infrastructure, without any change to the vehicle, it works as it is right now.
That means that if you have a vehicle today, you don't have to go out and buy a new vehicle to reduce your carbon emissions. You can just take this gasoline and immediately cut 40% of the CO2 from driving your car to work every day. So here's a way that we can affect an energy transition faster than by replacing the whole vehicle fleet.
I've been working on this project for the past 2 years, and it's just amazing to see it in the real world.
It's so incredible to see Chevron taking this step towards renewable gasoline.